Hello students, in this video we'll be dealing with questions of Pythagoras theorem, particularly of the types where we have to prove RHS equal to LHS. These kind of questions come very often, and the way we are going to tackle these questions in this video is the recommended way what you should do. For example, if you see this question, and this S and T are 2 points which trisect QR. That means QS is equal to ST is equal to TR. And you have to prove that PT square, 8 times this PT square would be equal to 3 times PR square plus 5 times PS square. Obviously, here we'll be using the Pythagoras theorem, that the addition of the squares of two sides of a right angle triangle is equal to the square of the hypotenuse of the triangle. Now, to deal with these kind of questions, what we are going to apply is that we are going to label the sides with variables which are suitable. We will be using the minimum number of variables possible. If there is an interlink between the two variables, like one side is twice the size of the other side, we'll call one side as 2x and the other side as x. So we'll put them in variables instead of labeling the side names. Like QS would be equal to ST would be equal to TR. So we'll call them as, say, x, x and x. Now PQ has no relation with x, hence we'll take a new variable, say y, and call it as y. In the LHS and the RHS looks bigger than the LHS. Solving wise, both are obviously equal. So we'll be starting with the RHS and try to get to LHS. Or we can start with either of them and get to the same thing. That means we'll start with LHS, get to the term in terms of x and y, and then we'll solve the RHS and get the same terms. Both can be done. Here we'll start with the RHS. See, RHS is equal to 3 PR square plus 5 PS square. Now PR is this one, the biggest one. This is the hypotenuse of this big right angle triangle. So that PR itself is y square plus the bottom, the other side is 3x. 3x the whole square. Be careful, don't write it as 3x square. It is 3x the whole square, which is in fact 9x square. Plus 5 times. Similarly, PS will write in terms of x and y. PS is the hypotenuse of this smaller right angle triangle. So it is y square plus x square. Do not forget the brackets. Now opening this bracket, we get a 3y square plus this is 9x square times 3, which is 27x square plus 5y square plus 5x square. So we have a 3y square plus 5y square, which is 8y square plus 27x square and 5x square, which is 32x square. Now have a look at the LHS where we want to get to. Say it is 8 times something, and we are already having in the RHS 8 common. So here we can continue and go to the LHS, or we can start with the LHS separately. I'll just continue and go and try to reach the LHS from here itself. So it is equal to 8 times y square plus 4x square. Now see what is PT. PT is y square plus 2x the whole square, which is 4x square. So you can write it as 8 times y square plus 2x the whole square, which is equal to 8 pt square, equal to your LHS and hence it is proved. You could have also started, if you don't want to write these two lines, you can stop over here and don't write this much, this bit. You can start with LHS and say LHS is 8 PT square, which is equal to 8 times PT square is your y square plus 2x the whole square. Open the bracket, you will get a 8y square plus 32x square, which is equal to your RHS, and hence it is proved. Now the good part about taking the variables is you don't have to worry about replacing say a ST with a QS where it is required, or a TR with a ST, or doubling it. What you have to be careful about is you have to choose the variables properly. Whatever information is given in the question, S and T trisects QR, that the variables should represent it. Once the information given in the question is in terms of the variable, you are bound to get the answer. We'll try another question. Again, this is a CBSE question 2008. Here, the ABC is the right angle triangle with right angle at B. Now what is given is D is the midpoint of BC. D is the midpoint of BC, and you have to prove something which requires Pythagoras theorem. Now that information that D is the midpoint of BC can be transformed in terms of variables as BD equal to DC, and calling both of them as say X and X. Now AB is independent of this. There is no connection given between AB and BD or BC or DC. Hence I will take a new variable and call it as Y. Now obviously the RHS is solving wise, it looks bigger, so we will start with RHS. Answer RHS is equal to 4 times AB square minus 3AB square. 4 times AD square, AD is the hypotenuse of this right angle triangle ABD, hence it is y square plus x square, minus 3 times AB square. Now AB is simply y, hence it is minus 3 y square. Bracket wasn't required. So this becomes 4y square minus 3y square, which leaves you with just a y square, and 4 times x square, 4x square. Let us see what is required in the answer. AC square. AC would be a y square plus 2x the whole square, which is already the answer. So you can write y square plus 2x the whole square, which is equal to your AC square LHS, hence 2. See, if you choose the variable carefully, if you choose the variable right, if the information in the question is transformed in your answer, then you are bound to get the answer, and the question becomes very, very small to solve. It looks also neater. Let us see one more example of this kind, where the vertical is also, the value of the vertical, like y over here, is also linked with the value of the horizontal. So we will not be choosing an independent variable. This will also be a dependent variable on x. Now this question says that ABC is an equilateral triangle. That means AB is equal to BC is equal to CA, and BD is 1/3 of BC. So if we call AB as x, BC would be x, and AC would be x, and BD would be x by. Now generally people feel difficult to handle variables in fraction, so we can rather name AB as 3x, BC as 3x, AC as 3x, then BD would be x itself. Now again what you have to prove is AD square is equal to 7 times AB square. AD square, AB square, all these look like the hypotenuse of a right angle triangle, but the right angle triangle is missing. What we have to do is we have to construct a right angle triangle such that we can put the values of these sides. So what we would do is we will drop a perpendicular from A. The perpendicular drop touches BC at P. Now BD is 1/3 of BC and BP will be half of BC because the triangle ABP would be congruent to APC. So if we call AB as 3x, BP would become 3/2x, again a fraction. So to avoid fractions, you can deal with fractions, it's okay. You can call AB as x also and still solve the question, but to make the question more easily solvable or to reduce the chances of error, we'll choose variable which suits us best. So AB we will call it as 6x, divisible by 3 also, divisible by 2 also. AC also will become 6x. BP whole leaf would be 3x. BD is 1/3 of BC. 1/3 of 6x is 2x. And since BP was 3x, this BP small part would be x. Now, for the Pythagoras theorem, we need the vertical also. Is the vertical independent of these variables? No. We know that in an equilateral triangle, the height of the triangle is related to the side of the triangle. If we have an equilateral triangle, say sides are AAA, then the height is a known thing. What is the height? We can call this side as A/2 and apply the Pythagoras theorem in this half triangle. We get the height y square is equal to A square minus A/2 the whole square. Hence we get 3A square by 4. This is your y square value. So y value will be equal to A/2 root 3. That means the height is root 3/2 times the side value. The height is root 3/2 times the value of the side, the length of the side. So root 3/2 times of 6x would be root 3/2 into 6x would be equal to 3 root 3x. Hence, we'll write the height as 3 root 3x instead of calling it a y. Now all the variables are set, we are ready to solve the LHS or the RHS. Now LHS is the AD square which needs to be figured out, and RHS is AB square. AB square is simply 6x the whole square. So we'll start with RHS. Answer would be RHS is equal to 9 times AD square, which is equal to 9 times AD square. AD is the hypotenuse of the triangle APD. Hence it would be x square plus 3 root 3x the whole square. So you get 9x square plus 9 times 3, 9 into 3 is 27x square. It is equal to 28x square. 1x square plus 27x square is 28x square. So we have 9 into 28x square. Now have a look at the answer. We have a 7 something, 780 square, which is we are also having a factor of 7. 28 is 7 into 4. So we already have a 7. We need not multiply this 28 with 9. Let's take out the 7 and it looks like this: 7 into 9 into 4 x square. And what we wanted was 7 AB square. AB square is 6x the whole square, which is 36x square. 9 into 4 is 36. Hence we are almost there. 7 into 36 LH 7 into 6x whole square, which is 7 AB square. This is your LHS, hence the answer is proved. We see if we are taking the variables smartly and we are taking the minimum number of required variables. Here the only variable required was x and not y. We are going to get the answer anyhow. Now one more problem I'll just solve for you to show that it helps. Instead of replacing say a BP with a PC, if you have written in the variables, you don't have to replace the side lengths. So last example on this. There's again a CBSE 2006 question. ABCD is a right angle. Sorry, it's a rectangle, and O is any point in the rectangle. It is not necessary that it is the midpoint, it is any point in the rectangle, so I have made it anywhere. And you have to prove that OB square, this side OB square plus OD square is equal to OA square plus OC square. Now obviously from the look of it, it seems that it requires Pythagoras theorem. Again we will be replacing the sides what we will be requiring in the Pythagoras triplet with variables. Now whatever information, it is just said that ABCD is a rectangle. Now what we know about a rectangle is that all the angles are right angled and the opposite sides are equal. AB would be equal to DC, AD would be equal to BC. So we can go on and name them like that. But before naming the variable, OB square or OD square or OA square, OC square, these line squares would come only when these are hypotenuse of a right angle triangle. So to make OB the hypotenuse of a right angle triangle, we can drop a perpendicular over here. OC, we can drop a perpendicular this side or on top. So what I'm going to do next is I'm going to make the required right angle triangles such that these side squares figure out in the Pythagoras triplet. Now I have dropped perpendiculars, is slightly inclined, but I intend to make them perpendiculars, the straight lines. Now AO square can be written as this side square plus this side square. Similarly, OB square can be written as this side square plus this side square. So all these sides AO, BO, CO and DO have become the hypotenuse of right angle triangles. Now we have to name the sides properly. So let this side, let the foot of the perpendicular be at say P, Q, R, S. We need not label it. Could have just written the sides. Let AP be equal to say, let this side length be equal to say A. Say PB be B. Say BQ, this is C, and say this one is D. So if AP is A, BR is also A, because APRD forms a rectangle again. All these are 90 degrees. Similarly, if PB is B, so RC is again B, ds is CQ, which is B, and QC is SA, which is again C. Now A, B, C, D, we have no relation between them, but the other sides are obviously related to the variables which are already taken. So we are not going to take fresh variables for say RC or DA, DR or DS or AS. The variables should be minimum in number, and whatever relation is between them, we will use those relations like AP or A, DR is equal to AP, which is again A. Now since we have named the variables, we'll start with either the LHS or the RHS. Answer. Say LHS. Since both LHS and RHS look the same, we'll work out on LHS as well as on the RHS and hope to get the same value. LHS is OB square plus OD square, which is equal to OB square is the hypotenuse of this say right angle triangle. In this, PB is B, OP will be equal to QC, which will be equal to C. If we name them all, this RC is B, OQ will also be B, because these are also rectangles found in between. This is B, and this is also B. This is A. Let me get back to the question, to the solution. OB. OB is OP square plus PB square, which is C square plus B square. And OD is A square plus B square, whichever triangle you look at. You look at this triangle and you look at this triangle. Both of them, B square plus A square. That is A square plus D square. So rewritten, it's A square plus B square plus C square plus D square. And let us look at the RHS. RHS is equal to OA square plus OC square. Now OA is your A square plus C square, whichever triangle you look at. A square plus C square. And OC square is B square plus D square. B square plus D square. So this is again A square plus B square plus C square plus D square. So clearly RHS is equal to LHS is true. What we see is we have done the hard work in the diagram itself, and in the diagram it is quite clear how the sides are same and what we have done. You can write a small, you could have written a small construction about the lines what we have drawn, or the diagram suffices. But what you have avoided is a lot of replacement of variables, which would have been required if you had not labeled them as variables. Now C square, B square, A square, D square. In the other line also you get A square, B square, C square, D square. So the two are same, and it is proved very short. The hard work is initially labeling the variables correctly. If you get your variables right, which is again not very difficult to do, but you have to carefully name them. Wherever extra variable is not required, you should not put an extra variable. Try to manage with the minimum number of variables possible, and you are going to get the answer very fast. That's it about Pythagoras theorem proving problem types. And if you are comfortable with the variables, then only use it. Obviously I am teaching it because this way it would be much helpful in future in a class 11th and 12th when you are using variables. You can't be using the side labels forever. And if you are not comfortable using the variables, do as you have been practicing. But remember, these questions are very easy, very solvable. So best of luck with these questions. Okay.